Okay, class, here's the second video. This is dealing with lesson 7.1.6. So again, what I'd like you to do is have one person watching the video and one person taking notes, and then at the end, share your notes. The objective of this lesson is to develop the unit circle, but in radians. We're going to skip quite a bit of the assigned problems in this lesson, and we're going to go straight to developing the unit circle. So if you can forward to a slide that has the unit circle on it, we will complete the top portion of this, and then maybe we can get to the bottom half also. Now, from our previous work, we talked about every point on a unit circle, no matter where it is, right here, having the coordinates of x, comma, y, where x is equal to the cosine of theta and y equaling the sine of theta. Now we've done this in degrees, but now we're going to do it in radians. So let's label, and let me erase what I just wrote. Let's label some of these angles in terms of degrees and radians. We're only going to take a few of these points, not all of them. This point right here, given this angle is theta, is 30 degrees or pi over 6 radians. This point is 45 degrees or pi over 4 radians. And this point right here is 60 degrees or pi over 3 radians. And up here we have 90 degrees or pi over 2 radians. Now, from some previous work with Ms. Larson, I believe, you talked about the cosine of 30 degrees and the sine of 30 degrees. And the cosine of 30 degrees was the square root of 3 over 2, and the sine of 30 degrees was 1/2. Well, it doesn't matter whether you are using degrees or radians, that point on a unit circle that has a radius of 1 unit is still the square root of 3 over 2, comma 1/2. Now you can verify that on your calculator by going to your calculator and typing in the cosine of 30 degrees. And if you were to type in the cosine of 30 degrees in your calculator, it's going to give you the equivalent of the square root of 3 over 2, which is 0.866. And if you type in the sine of 30 degrees, it's going to give you the equivalent of 0.5. So just take a minute, make sure your calculator is in degree mode, and type those in. And after you have verified that, then come back to this video lesson. Okay, hopefully you're back now. And you've shown that the cosine of 30 degrees is 0.866, which is equivalent to the square root of 3 over 2. And the sine of 30 degrees is equal to 1/2. Well, if you switch your calculator into radian mode, and type in the cosine of pi over 6, you'll get 0.866. And if you type in the sine of pi over 6, you'll get 0.5. So if you're in either mode, you still end up with the same coordinates because the location on this unit circle is the same regardless of degrees or radians. So up here at 45 degrees, which is now what we call pi over 4 radians, that will be, or have the coordinates, of the cosine of pi over 4, comma, the sine of pi over 4. So make sure you're still in radian mode with your calculator and type in the cosine of pi over 4 and the sine of pi over 4. What you should get is a value that's equivalent to the square root of 2 over 2 for both of these. So pause this and see if you get something that's equivalent to the square root of 2 over 2. All right, now that you're back, hopefully when you typed in the cosine of pi over 4, you got 0.707, which is equivalent to the square root of 2 over 2, and the sine of pi over 4, which is also 0.707, or the square root of 2 over 2. Now do the same in radian mode of the cosine of pi over 3. Let me try that again. The cosine of pi over 3 and the sine of pi over 3. And what you should get for this point right here is 1/2, comma, square root 3 over 2. Let me fix that. And up here at 90 degrees, if you type in the cosine, up here at pi over 2 radians, if you type in the cosine of pi over 2 and the sine of pi over 2, you should get the points or the coordinates of 0, 1. Okay, so now you've got the coordinates of 0, 1 up here. And if we start looking at symmetry, this is what we call quadrant 1. And notice how all of your x and y values are positive. Now I'm going to try to erase some of this work so that we can actually take a look at what's really up here. And what we have is, at this point, a positive square root 3 over 2, comma, 1/2, where the square root of 3 over 2 was a cosine of 30 degrees, and the 1/2 was the sine of 30 degrees. Well, if we use symmetry and we go now into quadrant 2, this point was on the x-axis, the square root of 3 over 2 over. Well, this point over here is the same distance but backwards. So this has the coordinates of a negative square root 3 over 2, comma, the y value was a positive 1/2, and this is still a positive 1/2. And so the coordinates of that point happen to be a negative square root 3 over 2, comma, 1/2. The coordinates of this point happens to be nearly the same as what we have here, except the x-coordinate again is backwards, or on the negative side of our x-axis. So this is going to be a negative square root 2 over 2, comma, square root 2 over 2. And the coordinates of the point up here is going to be similar to the coordinates over here, except the x-coordinate is negative 1/2, comma, and the y-coordinate is still a positive square root 3 over 2. Back to this slide and determine, so I'm going to adjust this just a little bit and erase some of this work, and you may have to adjust your Notability file a little bit also. So now, taking these points that we had in the first quadrant and reflecting them down, I'm going to start with that point. It's going to be right in the middle. And if this point right here is going to have the coordinates, x is still negative, so it's going to be a negative square root 2 over 2, comma, but now y is a negative square root 2 over 2. This point would be right about here. It's also going to have a negative square root 3 over 2 for x, because we are going backwards, or we're going into the negative side on the x-axis. But y is also negative because we're going down, so that's going to be then a negative 1/2. And this point would be right in here. And those coordinates, again, a negative 1/2 because we're going back, comma, but now we're also going down instead of up. So that's going to be then a negative square root 3 over 2. That's quadrant 3. Then in quadrant 4, we can use either quadrant 1 or quadrant 3 to help develop this. But if I take this point right here and reflect it, I'm going to be down here. X is positive because we went over a positive square root 2 over 2. But now instead of going up to a positive square root 2 over 2, we're going down. So that makes this a negative square root 2 over 2. This point is going to be right in here if I reflect it. And the x-coordinate stays the same, square root 3 over 2, because we're positive. But now we're going down 1/2. And finally, that point reflected is down here. We're still going over a positive 1/2, but now we're going down a negative square root 3 over 2. Now, what are the measure of all these points in terms of radians? Well, some of this comes from when we created that sine calculator on the yellow sheet previously. This is pi over 6, And this is pi over 4 in radians, and this is pi over 3 in radians, and this is pi over 2. This point So hopefully you have room to squeeze this in. I added an extra slide to emphasize, if we were to ask you what is the cosine of pi over 6, you could take a look on your unit circle from the previous slide, and pi over 6 radians is right there. And this, again, is your x-coordinate, which means the cosine of pi over 6 is the square root of 3 over 2. If we asked you what the sine of pi over 6 happens to be, that's going to be your vertical distance right there, y, and the sine of pi over 6 is 1/2. If we go to this angle, that angle happens to be, from some of our previous work, in radian mode, 5 pi over 6. That's how far it is from our x-axis all the way to that angle measure, or to this other side of our angle. And so the coordinates of that point, let me color coordinate this. The x-coordinate is going to be the cosine of 5 pi over 6, which is the same, or excuse me, just the opposite of pi over 6. So I'm going to be going back a negative square root 3 over 2. And our y-coordinate is the sine of 5 pi over 6, which is equal to the same height as over here, which is 1/2. So using some of these ideas in this symmetry, it is possible for us to